Lunar Society literally spawned the most important scientific idea of the 19th century.
Hi everyone, my name is Steve Guerrero and I'm the Director of Education here at the Charles River Museum of Industry and Innovation. You're sitting in what was the power plant of the Boston Manufacturing Company, started by Francis Cabot Lowell in 1813. I'm really excited to have tonight's speaker because our museum's mission is to talk about the Industrial Revolution and how it revolutionized the way we live and the way we work and how technology has shaped our lives and will do so in the future. Tonight's speaker is David Mindell. He's a MIT professor of aeronautics and also of the history of engineering. He is someone that has thought deeply about the way technology has shaped our lives through history, specifically through his look at the Lunar Society, and now has a posit for us to think about the new Lunar Society, the way that we can kind of grapple with the future of technology by exploring and grappling with the past. Without further ado, I would love to introduce David Mindell. David.
Thank you. It's a great pleasure to be here. I almost couldn't think of a better place to talk about this book than the place we're standing in right now, which will become apparent over the course of the, as I talk about the book. I wrote a book 2 or 3 books ago about the Apollo guidance computer, which has a chapter on manufacturing, and as many of you may know, that was manufactured here in Waltham. I don't think the building exists anymore. I think it's about where the Sam's Club is over on Grove Street. And I say that because another great Waltham connection is the company I started, Humatics, is here in Waltham. And used to be over on Grove Street, is now on Beaver Street. But one of our kind of founding scientific advisor was Dave Scott, who was the commander of the Apollo 15 mission, and also a graduate student who worked on that computer and had been at that factory. And he came out to visit us. You must have been there, Chris. And he was sort of like, yeah, it was kind of over there, as I remember the building. So I don't think the building's here anymore. I haven't been to the town archives to find that out, but that in itself is an amazing story about classic American manufacturing being upgraded through the textile industry and into the electronics industry. And again, as you know, the textile industry in Waltham, combined with the precision machining industry, had a lot to contribute to the birth of the computing industry here in New England. This book is called The New Lunar Society, an Enlightenment Guide to the Industrial Revolution. And it's unlike any other historical book I've written in that it's 40 or so very short 2-page chapters, and they alternate between the 18th century and the present day, which can be a little bit vertiginous for a reader if you're not careful. And but I've been working a lot on what's happening today as we try to revitalize American industry. And interestingly enough, it's something that both political parties, maybe the only thing that both political parties in Washington agree on, that this is a good goal. They don't agree about how to get there, but everybody agrees we should be doing it. And there's any number of questions about what does it mean to revitalize, what should we be making here. And those are all questions that I'm interested in, I've been working on for the last 5 or 10 years. So this is a historical book, but it's very much about everything going on today in this era of pandemics, climate change, political instability, global realignments, all happening while we're poised on this new era with new approaches to intelligence, new approaches to work coming out of the pandemic era. What does it mean to know something? At the same time, the 18th century story is amazing and mind-blowing. I think of it as a steampunk fairy tale that actually happened. And the book is not about policy. In fact, I have been working on an article with some colleagues. What should the administration be doing now? And I'm actually hesitant to wade into that. I've done a lot of policy work. It's really about the human dimensions of industrial improvement. And any policy the government sets is going to fail if the country doesn't sort of get behind thinking about things in a different way. I'm sure I'm preaching to the choir in this environment, in this town, But this book is really written for young people thinking about going into industrial careers and working in industry. And actually just walking up, really the key word in the text is actually in the name of this museum, which is industry. Industry is a human virtue before it is smokestacks and factories. And the Industrialists revolution actually preceded the Industrial Revolution, people working in regular ways toward a common goal. And the book is really about that kind of industry as a basis for American democracy. I'll say a little bit about Ben Franklin, and Franklin's autobiography was for 150 years the most popular book in American history. And really, it's only about 50 pages long, but it really created the kind of rags to riches story that Americans modeled themselves on. And a lot of self-mythologizing going on there, but it was very effective. And in those 50 pages, Franklin uses the phrase industry and frugality 35 times. So it's a very key word for him. And he did not mean manufacturing. And he did not mean the Waltham Watch Company. He meant the kind of work he did as a printer in Philadelphia when he was starting his career. Okay, let me start with this image. When you look at this image, you may see something that looks colonial or antique or from 250 years ago, which is all correct. When I look at this image, I see manufacturing, because in addition to the stockings, which would have been made on something like an Arkwright stocking frame, the buckles on the shoes, the buckles on the hat, the buttons, and the sword and the sword hilt were very likely made in Birmingham, England, in the Northwest, in the Midlands. And in the 18th century, it was a very poor place. There was literally no road even to get to London from Birmingham. But it was already the capital of what they called the toy industry. And in later years, actually, interestingly enough, Birmingham gave us J.R.R. Tolkien and Robert Plant from Led Zeppelin. But in the 18th century, it gave us toys. And they did not mean children's toys. That was not the way the word was used then. It really meant small metal objects, very much like the objects on this gentleman's dress. And they were inexpensive. They did not require a lot of capital. They were low precision. They were easy to transport. And Birmingham manufacturers were constantly doing these wonderful innovations. My favorite one is, this was also right about the time when aristocrats began wearing diamonds, a colonial extraction, on their clothes. And Birmingham manufacturers, including Matthew Boulton, who I'll talk about in a minute, figured out that you could take ordinary steel and just polish the heck out of it and make jewelry out of it, and in the low candlelight of an evening, it would look like a diamond bracelet or brooch. And they made a lot of money doing stuff like that, which was enabling middle-class people to feel like they were something like the aristocracy. And that's a huge theme in this whole story, actually. Matthew Boulton is likely the manufacturer who made those buckles. And maybe the only place that would be more fun to give this talk than here would be the Soho manufactory outside of Birmingham, but the factory part of it doesn't exist anymore. And by 1760 or so, Boulton had established himself as a rising manufacturer. He inherited a small machine shop from his father. He married very well into a fortune, and he used that fortune to build a new water-powered machine shop just outside of Birmingham, and innovated in the division of labor, innovated in the use of water power and mechanized tools. Interestingly enough, none of that was known to Adam Smith when he wrote The Wealth of Nations, with the famous example of the pin factory. And Boulton was this incredible character. In fact, maybe I'll read a paragraph from the book about Boulton. Few can claim, as Matthew Boulton could, to have been present at the founding moments of the Industrial Revolution, to have instigated key elements, and to have imagined it all in advance. Engaging, social, and matter-of-fact, Boulton possessed high technical skill in his trades, but also the humility to know when excellence had come to him. His curiosity both created the Lunar Society and enabled him to see the future of industry. Entrepreneurial drive coupled with a lack of pretension gave him an eye for fashion and ability to sell his products to the social aspirations of consumers. He dressed kings and queens, and he helped common people dress like royalty. And in fact, his factory was a very common stop on a kind of industrial tour. And the list of people he hosted in this factory, you know, Lord Nelson and his wife, Lord Hamilton and his wife, Lady Hamilton, and her lover, Lord Nelson, all would come through this factory and see the wondrous manufacturing going on. Bolton became very close friends with a kind of similarly aged up-and-coming physician in town, Erasmus Darwin, who later became Charles Darwin's grandfather. And they both became very enamored of Benjamin Franklin. Franklin had already published his famous work in electricity in the 1740s and was not only the most famous American scientist in Europe, maybe the most famous American in Europe, and he was actually living in London at the time as a representative for the Pennsylvania Assembly. So they invited him up to Birmingham to visit, and he actually came partly to visit his friend John Baskerville, who was the namesake of the Baskerville typeface, which we still use today, and did a bunch of electrical experiments with Franklin. He taught both Darwin and Bolton to experiment with electricity, which was very new and mysterious and interesting at the time. And after he left, they became inspired and said, we need to begin gathering our friends to talk about Enlightenment science. This is about 50 years after Newton's death. They're just beginning to become kind of engineering textbooks, versions of Newton's work. And there's a lot of interest in these big questions around the history of the Earth, the creation and generation of heat, the measurement of any scientific quantity, various chemical curiosities. And over the course of the next 40 years, Bolton hosts at his house every couple of months this group that comes to be known as the Lunar Society. And the house from Soho is still there. You can go visit it. I was there last April. And there's the room right in the first floor there where the dinners were held. They called it the Lunar Society because they met on the full moon so they would have enough light to walk home. And, but the group never had any official status of any kind. There were no membership lists, there was no dues, there was no charter. It was just a group of people getting together, talk about the scientific questions of the Enlightenment, and think about how to apply them to industry. And over the course of that period, there were this incredible group of people became part of the Lunar Society. Joseph Wright, who's a painter who painted all the kind of classic pictures you see of Enlightenment science. James Hutton, who kind of created the foundation of a modern geology, the idea that the Earth could have a history at all, that's recorded in the rocks that you see. Joseph Priestley came a little bit later, famous, very radical clergyman, but also a very important chemist, and next to Lavoisier, the father of modern chemistry. John Wilkinson, who would later really create the machine tool industry nearby, and many, many others. And through this Lunar Society and this sort of congregation, again, none of those people became known because they were members of the Lunar Society. It's not unlikely that many of them were influenced by the Lunar Society and therefore did great things. And one of those people who you've probably never heard of was a guy named William Small. And Small was a physician from Scotland, and the Scottish version of the Enlightenment plays a very important role here, not least because the Scots they had been peaceably admitted into the British Empire early in the century, but they weren't really socially accepted. And many of them were not part of the Anglican Church, and almost all of the Lunar Society members were, and I love this phrase, it's a formal church term, they were radical nonconformists. And I want to do something in my career that earns me that title. The fact that they were not only not in the Anglican Church, but that also meant they were excluded from Oxford and Cambridge. And because of that, they actually created their own little educational system. High schools that became known, also a school I wish I had gone to, they became known as dissenting academies. And there was one called Warrenton, where Priestley had taught, that Wilkinson went to, that generated many famous thinkers, including Thomas Malthus, the economist. What's great about the Lunar Society is this is the British Empire kind of at the height of its powers, right at the end of the 7 Years' War. King George III has just taken to the throne. But these folks are peripheral bumpkins up there in the Midlands with barely a road to them. They are not prestigious London thinkers, or many of them become members of the Royal Society over the course of their careers. But it's important, actually, that they're peripheral. And kind of develop this novel idea that maybe you could actually be a manufacturer and do great things, as opposed to the prevailing idea, which was that a manufacturer was a low-grade worker technician. So William Small is a physician also, and he goes to Virginia, and he gets his first teaching job at the College of William and Mary, and shows up there after his 2-month arduous journey across the Atlantic. And they say, well, you know, last month we fired all of the faculty for alcoholism. You're going to need to teach every class until we can hire a new teaching staff. And so Small does what he knows how to do, which is he doesn't really have a reforming spirit, but he does end up reforming the theology and law curriculum around history, demonstration, science, and he brings a Scottish Enlightenment curriculum to this school. And he teaches every class at the school for the next 2 years. And an amazing coincidence is that one of his students who is there for those 2 years, who takes every class he took in college with William Small, is a, sort of callow young slaveholder from Virginia named Thomas Jefferson. And to the end of his life, Jefferson credited Small with infusing him with Enlightenment principles. And the great historian of science, Bernard Cohen at Harvard, has traced that through even the opening sentence of the Declaration of Independence, where the phrase, the laws of nature, is used, which is a Newtonian phrase. A lawyer or a philosopher would use the phrase natural law. And there are these other echoes of Newton throughout the Declaration and other aspects of Jefferson's work. So you have this, from this very early stage, you have these very subtle but deep connections between the Lunar Society members and the founding of the American Republic. Actually, Benjamin Franklin comes through town, and he has dinner with George Washington and William Small. And Franklin says, "You don't really belong here. This is a backwater. I'm moving to London. Come with me, and I'll take you under my wing." So Small leaves the college. He goes back to London, ostensibly to buy scientific instruments for the college, which he does, but he mails them back, and he actually never returns. He hangs out with Franklin in London and goes to the Royal Society with him, and is kind of introduced to the mainstream scientific Enlightenment. And then Franklin says, "You should go up and see Bolton in Birmingham," which he does. And the two hit it off. Small is actually a very gregarious character. He's very social, he's very outgoing. And he quickly goes back to Scotland to get his medical degree, moves to Birmingham, and becomes a physician there, and begins kind of curating this Lunar Society. He's a connector, very important role. But one of the reasons you've never heard of him is he didn't publish his science, he didn't do research really, he just brought people together. And one of the first things he tells Bolton is, I was just back in Glasgow meeting some friends of mine, and one of them is this scientific instrument maker at the University of Glasgow. And he's an incredible character. He will has his own workshop on the campus, and many different of the professors would come in and just hang out and watch him work and listen to him talk about making scientific instruments, including Adam Smith. He thinks he has this idea to build a better steam engine, but he can't make it work, and he doesn't have the skills and the capital to make it go. You should meet this guy. And that young scientific instrument maker is James Watt. And Watt had been struggling for 10 years at this point to try to create this thing, there were steam engines before, but he invented what became known as the separate condenser, which is the thing that made a steam engine practical and economical as a tool. And he had an investor who wasn't really very supportive. And Watt's a very interesting character. He's not confident, he's depressed, he's sort of a loner, he doesn't really believe in himself. But he's very, very skilled at instrument making. But in order to build this kind of steam engine he wants to build, you need to take a scientific instrument, not unlike the steam engine model here. Beautiful brass thing made with great precision in London about 50 years after Watt's time. But that's not a useful steam engine. You need to make one the size of this building, and you need to make a scientific instrument the size of this building. And that's the thing, today we call that scaling up, that Watt couldn't do. He said, I lack the skills for engineering in great. It's a great phrase. And not least he couldn't do it because he was a bad manager. He did not relate well to the workmen. He didn't know how to manage people. And I'm sure he came off as arrogant and dismissive of the millwrights, who was a critical kind of early engineering skill. And so he comes, Small brings him to Birmingham, and he and Bolton meet. He visits the Soho factory with Bolton and ends up staying for 2 weeks. And the two of them really hit it off, and this is the point where Bolton has actually been experimenting with steam already in his own work. He's got a water-powered factory. It's a pain in the butt because it dries up in the summer and it freezes in the winter. And he knows what steam power can do because he's a user. He needs it. He's a factory owner and manager. And very quickly, Bolton says, come down here and work with me and get me a license to the steam engine. And Watt takes that under advisement and goes back and meets with John Roebuck, his investor. And Roebuck and Watt send Bolton a proposal that says, we'll license this engine to you for the 3 counties around Birmingham. And Bolton says, no way, not interested. And this is the letter that he writes back to Watt. My idea was to settle a manufactory near to my own by the side of our canal. So he's not just thinking about making an engine. He wants to make a factory to make engines, which is a first. By the side of our canal, where I would erect all the conveniences necessary for the completion of the engines, by which we would serve all the world with engines of all sizes. We would engage excellent workmen, we'd get them excellent tools, 20% cheaper than otherwise. And again, he gets this key point with as great a difference in accuracy as there is between the blacksmith and the mathematical instrument maker. And this is very similar, that happens over and over again, but if you think about the early electronic semiconductor manufacturing, you needed to take tools that were basically tuned for a scientific laboratory and bring them to a manufacturing operation. Pretty challenging thing to do, very similar with this early steam engine. And then he says, it would not be worth my while to make it for 3 counties only, but very worth my while to make it for the whole world. And I think this letter, and even this particular paragraph, this is the founding document of the Industrial Revolution. Bolton sees much bigger than Watt is able to see. So they don't make a deal. A year or two later, Watt's investor goes bankrupt. His creditors don't know what to do with these big broken pieces of an unfinished engine. And Bolton picks it up for a song, but he doesn't exploit Watt. He brings Watt to Birmingham and they form a partnership that's a pretty equal partnership. Then they begin making engines for pumping out mines. And they go to Cornwall, they start pumping out copper mines and coal mines. And within a couple of years, they've made a couple of dozen engines, and they pay off their debts. And Watt is a pretty happy guy. He's been at this 20 years. He's tired. He's depressed. He doesn't have the confidence to move forward. And he says, we're done. Like, that's a pretty good business. Thanks very much. And Bolton says, oh, no. You're coming back to Birmingham. And the point here is not mining. This is not where the action is. The point is to make an engine that will drive a factory. And to do that, I need a rotating engine. And the engines that they had been making were reciprocating engines. They had a big walking beam on the top that would go back and forth to drive a pump. There were senior, very well-known engineers at the time who said, you cannot make steam drive a rotating engine. Bolton didn't agree with that, and he knew that not only he, but other manufacturers who we worked with needed a rotating engine. So he brought Watt back, you know, oversimplified, but more or less stuck him in the back of a room, was actually in Watt's house. And all Watt did was make drawings for 4 years. And those were actually the 4 most inventive years of his career. And he makes 4 key inventions that are absolutely essential to making a steam engine practical. Actually, I think they're all on this brass model back here also, but this picture captures it nicely. So first he makes the sun and planet gear, very Newtonian name for the mechanism, that enables the reciprocating motion to be turned into the rotating motion. Today we would just call this a crank. In fact, it was really a patent issue that made Watt not use a simple crank. Watt had probably made the patent, he had probably invented the crank drive. Somebody stole it from him and patented him, but he was very paranoid about his own patent, so he didn't want to take any risk he would violate someone else's. So this is a beautiful thing to watch. There's actually, you can see them in the London Science Museum, but they didn't last very long. The other key invention was the double-acting steam, where the steam is both pushing the piston in both directions, whereas earlier it had only pushed it in one direction and the atmosphere would push it down. And to do that, you needed this very high precision valve gear, which was almost unmanufacturable at the time, but Watt made it. And there are a couple of original Bolton and Watt engines operating in England, and if you see them, the valve gear is like a mechanical ballet to watch. It's a beautiful thing to watch, and it's mechanically so you operate it by hand to get the engine going. So the valve gear for the double-acting piston, then you need the beam to not only push but also pull, not only pull but also push. It had been a chain, now you need a rigid shaft to drive the piston, but the beam has a circular motion and you need this piston to move very straight up and down. And Watt invents this beautiful parallel motion, which is sort of the drawings which he made it with are just works of art, and the way he coordinated all the pieces that rigidly couple the rotating motion into this mechanical motion. And then, by the way, the last one, my favorite, because I've written a book about this, is the flyball governor. And again, I've never given a talk where there's 3 flyball governors right here. And this is a crucial invention because it regulates the engine. In a sense, it turns the steam engine into a giant clock. It makes it into a precision instrument. If you add load to the drive output, it doesn't change the speed. If the steam pressure varies a little bit, it all stays constant. That's crucial if you want to do something like drive an a textile factory, because if it's varying up and down a lot, you break all the threads. So the flyball governor, which becomes a kind of icon of mechanical motion during the Industrial Revolution, is a great invention. And a lot of people see it as the first industrial feedback device, kind of predecessor of modern cybernetics and control systems. So one lesson here for today, of course, is that Watt's great invention of the separate condenser, which isn't even shown on this picture, still required 20 years of work to make it go, and all of these are auxiliary inventions to make them go. And once they make this machine, actually the first customer is the Whitbread Brewery in London, and the king goes to see it. It's a big deal, and they begin to sell a lot of them, and very quickly they become wealthy men. And the Bolton and Watt steam engines are the kind of great first generation of steam engines. And, but again, driving factories, not pumping out mines. That was Bolton's vision that Watt himself lacked. Okay, let me zoom out to the present day, and I'll go, taking my time, so I'll go through it. A project that I led with the labor economist David Autor and Liz Reynolds, who is a ran manufacturing and supply chain in the White House for Biden, although this was just before that, on this question of what is going to happen to work in the future. In fact, this project was 2018 to 2022, and so you may be aware there was a slight disruption in the middle of those years. And in 2018, people were coming to MIT and saying, I need MIT to tell me if a robot is going to take my job. And pretty quickly, we actually concluded the demographics are such that the problem is going to be not enough robots, probably not too many. There's very few things you can say about the future. One of the things you can say about the future is how many 20-year-olds will there be in 20 years? And there won't be enough. And the pandemic is an interesting story there because in June of 2020, there were 20 million people unemployed, spiked way up, and then that number came way back down, and you were back into a situation of labor scarcity again very quickly. And we looked at this graph, which is pretty well known among economists. They sometimes call it the Great Divergence, where from 1948 until now, productivity has kind of increased linearly due to, I think about Microsoft Word and Excel and, not AI yet here, but the 90s IT type revolution. And actually, mean compensation has pretty much tracked that. But the thing about mean compensation is all the people at the top pull that curve up here, okay? What happened around 1980 is that median compensation, which is the wages that most people earn, not affected by the Bloombergs and Bezoses of the world, diverged around 1980 and really hasn't come back. And so this gap has been an enormous problem. Actually, and economists are not totally sure even why it happened, except for you can say, the question is not, does technology improve productivity? It does. That pretty much literally means more work for less labor, right? The question is, who gets the benefit of that? And in this scenario, the folks here are not getting that benefit, or it's not nearly equally shared, right? So how do you take the benefits of the productivity and share them more generally in the economy? And this is another way to look at that, which is that, and again, this is a pretty common story that you've read about in the newspaper. If you're urban, professional, on the coast, doing IT, you're probably doing fine. David Autor would say when we did this, if you're college educated and you live in a city, you're not the problem. If you don't have a college degree, or actually the drawing point is 2 years or less of college, and you live in the country and your factory closes, it's very hard to rise up economically at all. Almost impossible, in fact. One of the things that's happened is that we've hollowed out the middle. And again, that's not news to you. You've seen that in the press for a long time. And the political and social ramifications of this curve are pretty obvious to us today and very, very deep and important and troubling. What I've noticed since then is we have a thing called technology readiness levels. There's a lot of ways to measure it. But roughly when people say this, they mean you have stuff that starts in the lab, it goes through pilot applications, it's then adopted at scale, and it enters scaled production. And almost always that curve is drawn from left to right. And all I've done here is flip that curve around. And you notice, so all the basic research kind of MIT, fancy coastal R&D jobs are here. And the production jobs and the security guards and the home health aides are here. But there's a known problem of getting a lot of this innovation out into production systems. I see this all the time in my work now. There are wonderful robotics startups all over Waltham, Massachusetts, who are starving because the adoption is not happening at the big customers quickly enough. And what I argue in the book is that this hollowing out in the middle has actually been really affecting that adoption. Because who are the people who do that adoption? I used to go to sea a lot with the Navy, and so the phrase there was master chiefs, which everyone knows on a Navy ship. It's the senior enlisted people who actually run the ship. The junior officers are sort of clueless college boys. They don't know what's going on. And that's true in a lot of factories too, right? It's the senior hourly workers or the senior production workers who really are familiar with the process. And those are the people you really need. They have the credibility with the actual process of what's happening, but also an ability to interface with engineers and new technology and figure out what is the right new technology to adopt. So these are kind of varying, pretty well-known problems as we think about how do we revitalize an American manufacturing base. Then I go back to some of the Lunar Society folks and I say, well, this is Josiah Wedgwood. You may have heard of him. Classic old English pottery. My parents got married in 1958. They got Wedgwood pottery for their china. And Wedgwood was a very poor potter because the entire British pottery industry in the 1750s was very poor, low quality, junky butter dishes and stuff. He was actually stricken by smallpox and couldn't actually do the pottery himself anymore. So he got interested in messing around with new formulas and became a kind of budding scientist on his own. In fact, Joseph Priestley took him under his wing and taught him how to record data and be systematic about his experiments. And Bolton was a hero to Wedgwood, and so Wedgwood became friends with him, started buying machinery from him, and modeled the growth of his pottery business. They were actually business partners for a while, but they couldn't make the metalworking and in fact, the sword that I showed you early on is one of the few Wedgwood-Bolton collaborations. So their business didn't succeed, but they stayed very close friends. In fact, he's Charles Darwin's other grandfather. The Darwins and the Wedgwoods were intermarried for 3 generations. So among other things, the Lunar Society literally spawned the most important scientific idea of the 19th century. And Wedgwood revolutionized pottery manufacture, and everyone was telling him, you can't compete with the Chinese. They make this wonderful fine porcelain. They've been doing it for centuries. They have this highly trained workforce. You'll never beat them. And within 30 years, his China is actually being presented by the British delegation to the Emperor of China. But he beats the pants off the Chinese in the English and the colonial markets, actually. Not least because he innovates in this design, and he's really selling Englishness with these classical themes. And George Washington is a big customer. A lot of the rich Americans want this stuff because they want to show that they're English. And he's selling Englishness, but he's also innovating in the glazes. He's sponsoring canal projects. The canal workers are digging up minerals and they're sending them to him, and he's collecting them and systematizing them, and develops this famous blue jasper ware, which is still known for. An amazing story. But Wedgwood is one of these people in the middle. He actually sells to the Queen. There's a real influencer dynamic going on. He makes a beautiful tea set for her, and once she's using it, everybody else wants it, so he makes cheap versions of it for the middle classes. What is the demand for this service, they call it? It's sugar bowls and tea sets. Both of those are colonial products, tea from China. The tea consumption in England triples and I think goes up by a factor of 20 over the course of the century. Same thing with sugar consumption. And the industrialist revolution, just like today's economy, driven by sugar and caffeine. And huge business, and he's doing very well with making these beautiful, industrially produced ceramic products. He actually starts to get nervous, and a lot of people are starting to get nervous about the slave origins of the sugar from the plantations in Barbados. Bolton and Watt steam engines are being used, but they're very brutal conditions that the slaves are working under. And there rises up an anti-saccharide movement. I love the name of about people who are boycotting sugar because of its slave origins. And Wedgwood's actually conflicted about this because he realizes he's making a fortune doing this, but he's not comfortable with it ethically. And he joins the earliest abolitionist movement in England in the late 1780s. And he contributes the way he knows how. He makes ceramics. And he makes this famous medallion which you can't see it, but it's an African slave in chains looking to heaven saying, "Am I not a man and a brother?" And he makes them pro bono by the thousands. He sends them to the US, to Benjamin Franklin, and they become, in London, sort of fashionable virtue signaling among wealthy patrons. They reappear later in the American Civil Rights Movement. Very famous medallion, and it's a great example of manufacturing as a source of social change, not as solely as the way that most historians narrate it as economic exploitation. And of course, as you're aware, the English abolished slavery 50 years before the American Civil War, and not entirely due to Wedgwood by any sense, but he makes a contribution. Another character in the middle, and here, if you go to the MFA, you'll see this painting by John Singleton Copley. And Copley was known for painting merchants, clergymen, and the upper elite of the colonial society. This is the only painting he ever made of someone who is not from that class. And it's an artisan with his tools, and not by coincidence a tea set, but this is Paul Revere. Also very much one of these characters in the middle. Revere is a silversmith, and so he's a blue-collar workman artisan. Artisan is really the relevant word. He runs his own business, but his patrons are the wealthy and the well-to-do who are buying his very fine silver work. This is another wonderful example of what's the federal style, but it's really the Wedgwood-inspired neoclassical style that Revere made. He's also in this in-between position, and that's actually the reason he's chosen for his Midnight Ride, where the anniversary was just last month, because he's able to work with the officers as well as communicate with the enlisted men. But after the Revolution, Revere becomes an early industrialist, and this is what Rob has written about, and turns his silver-making skills to copper and develops the first industrial rolling of copper, which is a very important strategic technology for cladding the sheaths of ships. And the British have already realized this, but this is after the war, and there's no access to British rolled copper, especially for something like this. In Canton, Massachusetts, Revere builds a copper rolling factory and rolls the copper sheathing for the Constitution, rolls the copper for the Massachusetts State House. Now it's fancy schmancy gold plate, but originally it was Revere copper. And really he's a proto-US industrialist, but very concerned with the ways that manufacturing contributes to the early republic. He's building bells, which bring the town together. He's casting bells. I think there are still, Rob says, 150 Revere bells around New England. He's casting cannon, which is another way of contributing to the good of the nation, and actually has what is likely the first contract of any kind from the federal government after the Constitution, when it's created to develop this copper rolling process. So super interesting story, and there are these characters who are throughout here who are sitting in this middle realm and developing industry, both in that human virtue and also in the sense of early manufacturing. So I'll move ahead just to wrap up. I spend a lot of time with a company that I founded with a partner called Unless, and thinking about how do we help companies that are doing what we call a new industrialism. And all the educational work that happens at the museum is a major kind of contributor to that sort of thing. But most of the financial system, Silicon Valley venture capital, if you've read about it, is all kind of based on 1990s software curves of adoption. And if you are working in improving industrial processes, that's not the way your business is going to grow or scale. It's going to be a slower start and then a much longer compounding growth cycle. And so we work a lot with companies to help them through that cycle. And I'll just go through a few of them, but most of them are interesting just for the young, well-educated workers who even 5 years ago would be sitting hacking at a workstation or a cubicle for Facebook, and now they're out welding, building, getting stuff out into the world. And that's really the kind of cultural change that we're looking for, and really trying to encourage people that, again, industry is a human virtue. Manufacturing industries are important for the health of the democracy in a bunch of different ways. We're not trying to reinvent the Waltham Watch Company of the 1950s by any stretch. But there are all kinds of reasons that there are new ways to think and talk about industry that need a kind of post-Silicon Valley way to talk about what does industry look like. And I'll read through some of those. Marry product innovation to process innovation. Avoid utopian innovation speak. None of the members of the Lunar Society ever said, in the future we will, and it's all going to be, rosy, futuristic, no people around kind of thing. Think in terms of systems, emphasize adoption, design for resilience and flexibility, a lesson we learned the hard way. We learn that the hard way now every month. The latest tariff shenanigans, as a friend of mine said, it's really just having a pandemic every month in terms of the disruption to business. But that's the world we're going to live in for a good while, is some kind of regular crisis. Get excited about maintenance and repair. I talk a lot in the book about how we've undervalued the maintenance of these systems as a form of process innovation. Value knowledge at every level of work. Again, a lot of the reason we got ourselves into this conundrum is the Ivy League trained managers, led by the economists, never understood the value that the frontline workers were adding to every production process. See human intelligence embodied in every product and system. Again, crucial for understanding in what ways AI might be applied productively to a system like this. And then finally, form your own lunar societies to collaborate and explore. So the idea behind the book is by no means to predict the future, even less to say we should go back to anything in the past. And I talk a lot about the limitations of these folks and what they missed. But much more to say, how can we talk about the future of industry in a way that is optimistic, but realistic and forward-looking at the same time? And we've not been given that language from the press, certainly not by politicians, certainly not by Silicon Valley. And it's really, again, the title I mean seriously, it's a guide for people to think and talk about the future of industry in a way that's human-centered and productive. And so I'll leave it at that. Happy to take questions.
Thank you so much, David. That was great. And I am even more excited that you're speaking here at a museum of the industrial working class, at the site where the American Industrial Revolution scaled. And we still have a lot to say here about the future of the working class. I would love to take some questions, but before I do, I want to thank the Lowell Institute for supporting our lecture series.
Thank you very much. Your Valley of Death is a multi-dimensional kind of model. It has a human scale, it has system scale, economic scale, and so forth. On a human scale, what do you think will define that Valley of Death in the future? You've got unskilled workers who are hands-on in a traditional model. You've got rather removed politicians and intellectuals on the other side. Do you see a filling of this valley by technology, by making for example, what role will AI play in enabling people who don't have formally conveyed skills? If a production worker is just someone working with some AI bot, it seems to me that would be very much an equalizing factor. So what will be the factors in the future that will define and perhaps change the Valley of Death for people?
Great question. Certainly right that it's multidimensional. Education is a big part of it, right? The education system has been too bifurcated in those ways. As you may have noticed, higher ed is under attack, not least because the system has become very good at plucking smart kids out of their small towns, bringing them to the big city, and then giving them big city jobs without giving a whole lot back to the small towns in that process. And I actually think the moats around places like MIT are much deeper and worse than they used to be. So we're very good at pushing the limits and pushing the sky, but we don't need the limits in the sky to transform industry right now. We need a lot of application of the stuff we have, right? And you know, I say this in the book, like, it's roughly 30 years to truly transform an industrial system from the time a technology works, because they're just that big and slow changing. And so if you're going to decarbonize by 2050, if you have any hope of it, even when I finished the book a year ago, we maybe had a hope of it. I don't know about that now. You got to do that with stuff you have today. We better take the things that are here on the table and really learn how to scale them, you know, and yet we spend all of our time and all of our smartest people pushing the boundaries, you know, doing the furthest thing, and then those things don't go very far because we don't have the right people carrying them out into the world. And the moats, again, are deeper and worse than they used to be. So there are interesting projects going around. You know, there's people thinking about it. Maybe there's a technologist degree that's a non-engineering production worker who's very comfortable with digital tools and is able to be in those interfaces. You know, there's a general public conversation about the overemphasis on the four-year degree. Most companies require four-year degrees, but when you look at the job requirements, they don't require that. And so at some level, it's a people problem at its core, and there are many different aspects of ways that we can think about going about that. There are, you know, we're great at encouraging people to form startups and fund them for a couple of years to have a good time building something new. We're not good at finding the people in the big companies or in government who have to make the hard decisions to adopt that stuff and take risks, because they are not in those organizations for those reasons. And so how do we match that stuff better? And companies like SpaceX just decided we're just going to do it all ourselves. And that's maybe viable. And I do talk in the book, like, a lot of this isn't stuff I invented. There are actually companies all over that are doing this stuff really well. And we just need a lot more of them, and we need the ones we have to be bigger. So I think about, you know, Commonwealth Fusion out in Devens, or a friend of mine runs an aircraft company in Burlington, Vermont. Whoever thought there'd be an aircraft factory in Burlington, Vermont, even 5 years ago? And you know, there's a lot of questions about a lot of these and how well they're survived, but at least they're pushing on changing industries that were considered unchangeable, just like Wedgwood did.
I will also say, next week we have a big group of students coming from Minuteman Regional Technical School. Mm-hmm. A little while back we had Blue Hills Regional Technical School, and there's great energy coming from those students in the vocational space.
Yeah, no, those are really important components that the U.S. has historically not had a great vocational ed system, and we needed to really do much better there. And there's a lot of kids who get pushed into college and they come out in debt, and they end up, you know, sitting in a cubicle doing some who knows what, that would be much happier working with their hands and making things. I mean, a lot of the companies I see, most of the big industrial ones, I think this includes Commonwealth, like, it's not at all far-fetched to say we could solve the energy problem by inventing fusion, and we'll be too slow to change because we don't have enough welders. And almost any energy company you think of is going to rely on welders, and they're totally too few and far between. So that's a great career to go into if you want to.
Hi. So one of the things that's interesting about this is specifically locating factories in urban areas, mm-hmm. and the sort of the nexus between urbanism, the sort of nascent urbanist movement, and industry. If there's one thing that America has been doing over the past century, it is taking factories and moving them out of cities to places that are as rural as you can get. Like Vance, Alabama in particular, is so very rural that, you know, people sort of have to leave work at 5 so they can drive 50-ish miles to get back to wherever they live. So one thing that struck me about this book was how urban everything is. When you don't have substantial transportation technologies, everyone has to walk to work. And I think a lot of the big labor relations stuff that happened was partly related to the fact that everyone is so tightly packed together. So one thing that I'd be interested in sort of thinking about is it possible even to do manufacturing specifically in urban areas in the United States today? And could that be what's holding us back?
Yeah, no, that's a great question. And there are a lot of people thinking about urban industrialization. And again, you just drive around Cambridge and there's all kinds of old factories around, right? And I actually think that there was an important cultural element to that where even in 1950, if you drove around Cambridge, much less 1900, or Waltham, you're seeing the places that are making the stuff that you may be not buying a fancy Waltham watch, but at least you have the sense like, I have a watch and it comes from a place like this. And you've probably heard of the place that the watch came from. And in addition to the other things that we've done by offshoring is we've made all this stuff invisible and pushed it away for both labor and environmental reasons. And I certainly talk about it in the book, just like one first step is just to make this all visible. And I think the pandemic, there's actually a chapter in the book called The Great Toilet Paper Crisis, because the pandemic had a way of making supply chains visible for people that no one thought about before. I worry that's gone away, but it's a good thing to think about where, everything comes from somewhere, and it has to get from there to here somehow. And you go crazy if you think about that for everything, but you should think about it once in a while for some things. And those things used to be painted on the side of the brick buildings in your town, and they're not anymore. Another way to think about the urban industrial thing is to what degree are technologies allowing us to decentralize and make more distributed production and cut what used to be originally you needed a big factory because you had one power system and the water wheel was distributed through the factory with leather belts. Electric power broke that up a little bit. What are you able to make in smaller, more distributed chunks? That's not a simple question. And my friends who do semiconductor work say, no way, we're just moving toward the $100 billion fab, and it's going to be very concentrated and capital intensive. I'm not so sure about that. There are, of course, economies of scale building of factories. That's where they came from. But they were originally done that way for social organization. The invention of the factory preceded the invention of the steam engine. And it was a social group of spinners and weavers to gather them in one place for purposes of coordination and time regulation, much more than, in fact, I was at a manufactured home factory in Nebraska a couple weeks ago. And it was the lowest tech factory I'd ever seen. There was literally not a computer screen in the whole factory. And it was like just a bunch of contractors all in one place. And the only technology was power tools. But it was just this sort of social organization of how you got the work done. And so I do want to encourage people to think about different ways. And there are people both thinking about it and also doing it. Again, there's an electric airplane company in Burlington, Vermont. That's a pretty novel thing.
Like a lot of people, I think my brain got stuck on the middle, that gap. And,
good. That's important.
Well, so I worked in prison for a long time teaching, and I got injured, and I switched to adult ed. But one thing that I noticed being here, because my mom worked in prison growing up, is in Boston, like Harvard and BU and BC, they would come in and they would teach classes to the students, which was amazing. And it just felt like, they had so much going on in their lives, so it was maybe not always stable for them to progress in the course, but it just felt like this untapped path, if they can move forward and be contributing in society, then doesn't that help everyone? And with adult ed now, I'm working with people with disabilities, immigrants, and I know there's a lot of grief and instability right now around all of those populations, but I don't know the answer. I just want to contribute that if there's a connection and you're looking to, as you mentioned this, I think you used the word moat around MIT, if you're looking to kind of expand, those are populations of people who, to be able to get, a GED is amazing. To be able to get a CTEC or some skill is great, but there always seems to be this barrier that it stops, and they would be a great population to really pour into, however that answers the question.
Yeah, no, that's a great point. And, on the one hand, Bolton and Watt and Wedgwood, they were always in conflict with their workers, right? It was never easy. And then the last thing you want to project back is a utopian agreement. And at the same time, when they felt like they were doing something that was focused and productive together, they really got amazing things done. A kind of thread running through the book, I think, is the moral value of working with the material world, and that the groundedness of whether you're hammering metal or weaving or, materials don't do what we want them to do, unlike data and Microsoft PowerPoint. I'm not sure that Microsoft PowerPoint does what I want it to do, but it's a lot harder to get away with BS when you're dealing with the material world. And I actually think that a lot of the knowledge work out there is alienating for those reasons. It doesn't always provide that to certain kinds of people, which can lead them to being lost and unsure. And there are many examples of people finding manual work, which again, we've denigrated in our culture, but is, again, you don't have to look too far in this museum to see the amazing things that have been accomplished. And how do you bring that to people in a way that can be transformative to their lives? And again, there are a lot of people out there doing it. We just need a lot more of them at a much bigger scale.
So there's a term from, 15 years ago or so. It was the title of a book called Slow Money. And another term for it is kind of social venture capital, where it's patient capital. And I think when you used the term, Silicon Valley, I think my sense was you were talking about the money and the venture capital imperative, fail quickly because this is not patient capital. And if we're not going to, so we're going to deploy our cash resources to 20 different ventures. We know that 12 to 18 of them are going to fail, but there are going to be some big wins here, and that pays for all the risk on all of the failures. But you've highlighted some firms. You're working in the area where slow money, where patient capital is really required. And what I'm curious to know is there a pendulum? Is the pendulum swinging in that direction? Or are the people who control the money say, nah, we're not going to wait because our imperative is to get rich, stay rich, and we know that this model is working for us even though it's not really helping the world.
Yeah.
And I don't know, I'd love to know your thoughts on what you're observing and whether there is a shift underway, which I think we agree we desperately need.
Right. No, that's a great question, and one could write a whole other book on that topic. On the one hand, always remember venture capital is a very small part of the overall financial system. And it has been very successful at what it's done, right? It's clearly spurred innovations that wouldn't have happened otherwise. But it's from a particular age and suited for a particular kind of technology, and from a particular culture also. And there are many businesses that are great businesses, but they're just not backable businesses, which is fine. And those businesses need capital too in different ways. Like the biggest thing you could do financially in this world for manufacturing is make it easier for small machine shops to get bank loans to buy new machines, right? Oops. That's a very difficult thing for them to do. and no venture capitalists will touch it. At the same time, venture capital, because of that short-term nature, most of it needs to sell out and wrap up its fund in 7 years. And most of these industrial firms, when they succeed, they grow for 30 years. And so they lose all that, right? So they're not good at capturing industrial change in that way. There's a lot of dimensions to it. But another piece of this, which is important to keep in mind, is that a lot of these technological innovations have also generated financial innovations in this country. And some of those financial innovations have been very important in supporting the growth of industry. And that goes back to the Boston Associates, right, who funded the original mills, was a rather different way to organize things. And we just need more of that in a kind of productive way as well. There was one other thing I was going to say, but I lost my train of thought on it regarding that. So there's a bunch of us at MIT thinking about that problem, both from the big scale to the small scale. Obviously, government has always provided patient capital in some ways, and that is probably under threat right now, too. That's a problem. You can sort of either fight it and work around it in different ways. And, you know, if it makes anyone feel any better, when you read about Bolton and Watt and all these guys, they're constantly struggling for money. All small companies are, and capital is always very hard to come by. So I don't know that we've solved that problem in any particular way. At the same time, it's the, you know, there's a phrase that pilots use, which is useful for startups too, which is go slow to go fast, right? Actually, when you hustle, you can make a lot more mistakes than if you go slowly and deliberately, and some of that, and a lot of the good companies do that kind of thing, so.
So we are all pretty aware that climate change is looming. And I'm wondering, with new industry, are the people involved, because with the original Industrial Revolution, we're still cleaning up messes. Is the new industry, or is new industry taking into consideration the big picture? Yeah, it's great to make new things, it's important, innovation is very important, but is, I guess, the climate considered in the process?
Absolutely. I mean, I think, so again, there's two things that the Lunar Society got wrong: environment and labor, right? So they had other models of industry that worked well that we want to learn from, but they missed those two not small things. We talked a little bit about labor. And they were polluting from the day they started. They knew that. Wedgwood was actually very concerned about lead poisoning among his workers. But, you know, I mean, Birmingham is not a pretty place, and it wasn't a pretty place then. We think differently about those two problems. Actually, part of the question in the book is, how do you rethink industry to take those two things inside? And if you just look at straight kind of climate tech, for lack of a better term, there was a movement in the US kind of up until about 5 years ago that was said, we're going to decarbonize by deindustrializing. Bike paths, you know, green spaces. I think one of the things that happened during the Biden administration, or at least it was enshrined in policy, is that you can only decarbonize by reindustrializing. You need better electric power generation that's less polluting. You need better distribution. You need you need to make concrete better. Nobody thinks about concrete, but it's a huge CO2 consumer. So the concrete industry is this really ordinary, stodgy, old, giant thing, and you're never going to decarbonize unless you change that industry. In fact, there's the big four people talk about, right? Oil, plastics, concrete, and ammonia. And if you don't deal with all four of those, there's no such thing as decarbonizing, right? Like, you're not going to get there by riding your bike to work. And so you have to reinvent our industrial systems from the ground up. That's a generation-long project. That's a worthwhile one that we need to be embarked on. And you have to make a lot of new stuff in order to do it. That's just a reality of it. So you have to figure out how to make those things in a less damaging way. And there are tons of people working on that and very energized by those problems. But that's what they're doing, right? And it's a great thing. There are PhDs coming out of MIT and other schools figuring out how to make low-carbon concrete. But who is it at the concrete company who's going to go, we need to change this system? That's the part they're going to hang. It's a brick wall they're going to run right into. And concrete wall, exactly. I don't know if bricks are lower carbon than they probably are, actually, because. So yes, I mean, but you have to make stuff to get through that.
Thank you for the talk. 2 questions. One, for the early factories, the early industrialists, how did they deal with their supply chains, whether it's materials coming into the plant or spares that probably had to be custom manufactured each time? Second question, on the gap diagram that you had, does healthcare follow that same mold or not?
Let me answer the first one first. So on the one hand, they had to work more with local materials than we do today. Well, obviously, they didn't have a concept of supply chain. At the same time, all these guys were big investors in canals. They knew they needed mobility. If you're in the pottery industry, bad roads are a real problem. And one of the great things about the Lunar Society, I think I mentioned this, is like the ways that the canal digging, dug up fossils that generated like a lot of these early geological and even evolutionary insights, and also minerals that Wedgwood would then use for his own experimentation. So they were very concerned with mobility as a system. And they had global supply chains in the sense of the sugar and the tea was being imported, but it was expensive to import finished goods, and so that tended to be more luxury stuff. And one of their great innovations was making that stuff for the middle classes. An interesting aspect, I didn't really mention this, but Watt didn't really realize this for the first 20 years, but they needed a machine tool industry to be invented before they could make a steam cylinder that worked. In fact, there's a great moment in the book where Bolton looks at one of the early cylinders. It's basically a big piece of tin wrapped in a circle and says, yeah, the tolerance between that and the piston is nothing. It's just about the width of an old shilling, right? They have no standards. They have no tolerances. They don't even have mechanical drawing. Watt invents a lot of that. But this guy, John Wilkinson, actually takes a cannon boring machine and applies it and learns how to bore a cylinder that's both very true and very round. And that's really the birth of the machine tool industry in Britain. And so they have no suppliers. They can't make this thing unless other people are rising up to build these pieces for them. And they have to worry about that all the time because they're inventing all the suppliers at the same time as they're inventing the industry. That's a hard place to be, but that's where they got to.
And he asked about healthcare?
What do you mean in healthcare?
Well, in that dip on that chart where you had in the center the master chiefs, first thing I thought, well, in regards to healthcare, is that in a way, maybe I'm being naive, but the master chiefs, isn't that analogous? forgive me, thank you, to like senior nurses.
Totally,
The
yeah.
people who, they're the ones who bridge from people who do the pure support work, people who clean the rooms, people who bring food, all the way up to the most experienced doctors. They're the connectors that bring those groups together. And that's why I was asking if you still see the same type of death valley in healthcare as you do in other industries.
Yeah, that's an interesting question. I don't really know enough about technology adoption in healthcare to answer that. The regulation of things like medical devices it is different in the way that you can sort of monitor how ready something is. Although I do think the principle is general that people who are really running stuff, they just got to get through their day. You know, make the trains run on time, deliver the boxes, you know, and it's a very high bar for them to change the way they do things for good reason, right? And I use a lot about the New York City subway system, which I've worked in a lot, which is a 24/7 system. You can't even shut it down to fix it without a huge amount of disruption. And so it's very hard to fix, and it hasn't changed in 60 years. You know, from those people's point of view, it's reasonable not to adopt anything new. In fact, it's normal and it's human. The thing that needs to be explained is why anyone ever bothers to do anything differently, because that's the weird thing. That's a risk that you got to try to understand. And so, but there again, you want people in those positions who have a deep level of knowledge and credibility with both sides, so they can really say, that will make my job easier. That looks like a science project, I don't want it. You know, that looks helpful. It's not going to ruin my people's work. It's going to help them. And that's just a crucial place to be. Interesting place to be if anybody, again, looking for career choices.
David, thank you very much. Thanks to our audience. If folks want to learn a little bit more, go to charlesrivermuseum.org/join if you want to help support our programming. But thank you for coming out tonight. Thank you, David.
Thanks.